All right, this is going on page 56 when we're done. And we do have 2 pieces of paper again today, with the second one having the application problems. So yesterday we looked at the change in linear functions that were related to arithmetic sequences. And today we're looking at change in exponential functions, which are related to geometric sequences. So we've seen when the output values of a function change at a constant rate, the function is linear. Now we're going to look at what happens when the output values change proportionally, okay, instead of them changing at a constant rate. When your sequence is geometric, the rate of change will increase or decrease as the value of n increases. So we have talked before about the rate of change changing, and that's what's happening when it's not linear, okay? So we have this graph here that has plotted points on the geometric sequence. Now, I took these notes from a different place and I edited them to make them what I wanted, but then I didn't realize until after I printed them that there were quite a few mistakes on here that I should have changed before I fixed that. Okay, who's this? Okay. Oh, it says that. I'm sorry. I was looking at the signature. But quite a few little things that are not correct that I should have caught before I should have just used the other ones is what I should have done, but it's okay. So this says A of n, this really should be a G. Okay, so anywhere there's an A, it really should be a G because it's geometric. So we'll kind of fix those as we go through. All right, so we're going to complete the table below, and we know that 1 is at 64, 2 is at 32. Can you really tell exactly where 3 is from the graph? No, okay? Not without guessing. Really, the rest of these would kind of be a guess, and we're not going to guess. But if I have a geometric sequence, I don't have a common difference. I have a common what? Ratio, yes. So I have a common ratio. And if this was arithmetic, which it's not, I would do 32 minus 64. But I'm not subtracting. I want a ratio, so I put 32 over 64. And what does that give me? 1/2. So R is 1/2. So I went from 64 to 32. The next one would be what? 16, then 8, then 4. So I'm feeling good because that was in there. And then 2, and then 1. Okay. So it said find the common ratio. Boom. We had to do that before we could fill that in. And write an explicit rule for G sub n. So our generic formula is G sub n is equal to G sub k times R to the n minus k power. We're going to use this one. Even though the 5 and the 4 are smaller numbers, we usually use the smaller n that we can. But it's not wrong if we use the other one. So this is going to give me G sub n equals, what's G sub k? 64 times R, which is 1/2, to the n minus what? 1 power. Okay. Now, when we substituted everything in with the arithmetic, then we could distribute and we could simplify things. We can simplify this or change it. If I use a different ordered pair here, then this would look very different, but I get the same answers in the end when I substituted things in. But let's say that I wanted G sub n to equal something times 1/2 to the just the n power, not n minus 1. Well, that would mean I would need G sub 0 and not G sub 1, right? So looking up here, what would G sub 0 be? 128. Because if I'm multiplying by 1/2 going in this direction, then I'm multiplying by 2 going in that direction. Both of those are acceptable. If it was a free response type of thing where you're writing it down, either one's totally fine. If it's multiple choice, either one could be a fair answer. So just got to understand how to get from one to the other. Okay, we okay on that? All right, good deal. I'll take that as yes. So then use the information from part B to write an exponential function that corresponds to the nth term there. And so basically we already did that, right? So we can say that f of n is equal to either 64 times 1/2 to the n minus 1 power, or f of n is equal to 128 times 1/2 to the nth power. And I'm not, you wouldn't have to write both necessarily, kind of depends on what the question's asking us for. But what I want you to understand is that these are just transformations of each other, right? This is taking this function right here and translating it to the right one. And then this is just taking this function, and we have a vertical stretch here. So depending on how you change it, you can take an original something and do different things to it, and then it looks the same in the end. Okay? What questions you got? Anything? All right. So let's look at this next one. It says, given the geometric sequence where this should be g sub 1 and g sub 3, and then this should be a g sub n here. So given the geometric sequence where you have these two values, we actually have a third one that's in there. That's great. We want to state the domain in the range of the function. All right, so domain we can go ahead and do. Domain is just going to be 1, 2, 3, 5, 6, 7. Because just like with the arithmetics, it's not continuous, right? Do I have enough information to write down my range right now? Can I write it down from the information I have right now? No, because I have a bunch of blanks in there, right? And I got to know what they actually are. So I need to figure out what they are. In order to do that, what we did yesterday was we needed the common difference, and then we were able to just fill it in. Here, I'm going to need the common ratio. Well, to get the common ratio, I would have to take whatever this value is and put it over 144. Or couldn't I take 36 and put it over whatever that value is? Would you agree with that? Like I could do it with any of them, but they have to be next to each other. Like me putting 36 over 144, not going to get me what I need. We agree with that? So we're going to call this one in here that we don't know, we're going to call it x, just so we have something to call it. So I know, let's see if you agree with me, that if I wanted to find my common ratio, I could put x over 144. Would you agree that that would give me my common ratio? Okay. Another option is I could pick 36 and put it over x. Would you agree that that should work too? Yes? So if both of those should work, then they should be equal. Yes? That little setup right there is what's called geometric mean. You do it in geometry, and when you're in, and I taught geometry for years, so I can tell you this with great confidence. When you do it, you have really no idea why you're doing it and what it means, because it doesn't make a whole lot of sense at the time that you're doing it. So let me see if I can kind of explain to you what the geometric mean means. First of all, when you're talking mean, median, and mode, what does mean mean? Average. Everything added together and divided. So it's average. So when you add things together and divide by how many you have, that's what you think of as average, right? That's actually the arithmetic mean. That's what, but we just call it average because that's really the only one we use. So if this was an arithmetic sequence, then the arithmetic mean, if I added these two together and divided by 2, that would give me this number, right? That's the arithmetic mean. But again, not an arithmetic sequence. So instead we need the geometric mean, and that gives us whatever number goes in here when you set it up like that. That's what the geometric mean is. If you don't know what it's called, it's fine. We set it up with logic before we ever talked about that, but just throwing that out there. It does have a purpose. It still may not make much sense to you. But we have to figure out what x is. We can cross multiply here, right? You've been doing that forever. So I'm going to cross multiply. I'm going to get x squared equals 144 times 36. And I'm leaving it like that because this would not be a calculator question. And I really don't care what 144 times 36 is. I'll show you why in just a second. I also don't care what x squared is. I want x, right? So I'm going to take the square root of both sides. So this gives me x equals. Now, this is multiplication and not addition or subtraction. That is why what I'm about to do is legal. What is the square root of 144? 12. What's the square root of 36? 6. So x equals, what's 12 times 6? 72. And that's what goes right here. Okay? Mm-hmm. What do you mean? Well, you could if you knew to do that. What if r wasn't 1/2? What if r was 2/3? You wouldn't know what to do. Does that make sense? So if you can reason through what it is logically, you can do that, but that's not going to work every single time. You have to have a process that's going to work. Okay? You with me on that? All right, so since I get 72 there, what is r? 1/2, okay? So now that I know it's 1/2, I definitely don't have to do that for all of them. But again, r can be anything. If it's 2/3 or 7/5, you trying to divide it out, that it's not going to work. You need something that will work for you every time like that. All right, so then this is 36, so what's the next one? 18, then what? 9, then 9/2, then what? It's 9/2 times 1/2. 9/4. So, because you don't really want to think about, you're not dividing by 2, you are multiplying by 1/2 because r is 1/2. And multiplying fractions is super easy. Then when we write down our range, we want to go from least to greatest. So this is 9/4, then 9/2, then 9, 18, 36, 72, 144. Okay. What questions do you have? Okay. So now we are going to, it says write an exponential function whose domain is all real numbers that will contain the domain of the sequence in example 9. And show your steps for writing the function. So to get to the function, we have to start with our generic g sub n is equal to g sub k times r to the n minus k. And just like I said yesterday, write that over and over again, and it'll get stuck in your brain. So I'm going to use this as my first one. So g sub n is equal to, what's g sub k? 144 times r, which is 1/2, to the n minus what? 1 power. Okay, so since I want it as a function, I've got f of n that's equal to 144 times 1/2 to the n minus 1 power. That's totally acceptable, but we have to understand how the other forms work, and we will look at some exponential rules and stuff a little bit later to look at it a different way, but f of n is equal to, so if I just want this to be 1/2 to the nth power, this is the first term, what is the 0 term? Which is 288. Very good, thank you. And both of those are fine. So this is kind of an or thing. What questions you got? All right, so we are going from geometric sequences to exponential functions, and then we're going to start looking at these as transformations of our exponential functions. So we've got so the explicit formula, that's what we've been writing here. The geometric sequence, and so this one right here is the one we've been writing down, and I told you if you only know one, this is the one you need to know, because it works even when you have the 0 term. But basically we've been putting it in this form and then changing it to that form, okay? It's a little bit easier than some of the other ways, trust me on that too. But these can be modeled by these exponential functions, which as you can see in here, you have some transformations there, all right? And it's based on the ratio and a point, okay? So let's look at example 11 here. We are given this sequence, so they give us a sequence. It is a geometric sequence, so it's an exponential sequence. You can see how that works on the graph there. And this is term 1, 2, 3, 4, 5, and 6. So this chart looks very much like what we had yesterday. So term number 1 is 3, term number 2 is 6, and then you can just fill all the rest of these in. 12, 24, 48, 96. So since it's term number 1, our subscript notation, this should be G sub 1. And then the next one would be G sub 2, G sub 3, G sub 4, G sub 5, G sub 6, and G sub n. That translates very easily into function notation. So G sub 1 is f of 1, G sub 2 is f of 2, and so forth. It's a good way just to practice your handwriting, right? Okay. So we're going to write these. We need G sub n, that's my subscript notation, and f of n is my function notation. In order to do that, I need r, and I need a starting point, so, or a G sub k, so we'll use this one, and we'll say we know that G sub 1 is equal to 3. We can use that as G sub k. What is R? 2. Sure it's not 1/2? Or is it 2? It's 2. Okay, R is 2. Our generic formula, G sub n, is equal to G sub k times R to the n minus k power. So G sub n, what is G sub k? What are we going to use? 3 times 2 to the n minus 1 power. Okay. When we get to the, can I go ahead and multiply 3 times 2 just to simplify that? No, totally illegal, don't do that. Okay, so then to get it into function notation, I can really just rewrite it, but since we don't have a lot of room here, let's go ahead and rewrite this one with the times 2 to the nth power. Let's put it in that form for our function notation. What would the 0 term be? 3/2, very good. So since I don't have n minus 1 here, now can I multiply the 3/2 times the 2? No, still totally illegal. Don't do it. Okay, we good? What questions we got? Yes, ma'am, I'm sorry. Oh, you're going to have to talk a little louder, I'm sorry. Oh, 100%, fraction over a decimal, yes. That's a very good question. Anything else? Yes, ma'am. Yes, that's fine. Yeah, unless it says specifically, which it doesn't really here, it is fine. I'm just writing them as both so we understand them both, but yes, that's the same thing. Absolutely fine. Anything else? Those are very good questions. Okay. Because my feeling, again, I can only have feelings about some of these things right now. My feeling about these questions is that they're not going to be ones that you're writing out like this most of the time. They're most likely going to be multiple choice type questions. So I want to make sure that you understand that these are the same and that they're both acceptable so you can match them up. So I'm good with either one of them as long as you understand what's going on. All right, anything else? Awesome. All right, so let's look at example 12. Given the explicit formula, and this one's really just a hot mess, we're going to make this, if it's going to be like that, it really should be f of n. I mean, a of n works, g of n, but that's not really consistent in what we're doing. Okay, we're going to write the first 6 terms of the sequence. So in order to do that, I need f of 1, which is going to be 6 times 1/2 to the 1 minus 1 power. What is 1 minus 1? 0. What is 1/2 to the 0 power? 1, and then 1 times 6 is 6. So our first term is 6. Do we need to substitute in every other number? No, because what is r? 1/2. So when I multiply, think about this, when I multiply 6 times 1/2, what do I get? 3. When I multiply 3 times 1/2, what do I get? 3/2. When I multiply 3/2 times 1/2, what do I get? 3/4. Then 3/8. Then 3/16. Okay? So that's 1, 2, 3, 4, 5, 6. And because we live in America, those numbers are important in the 8ths and the 16ths, because if you're going to measure anything in inches, it gets really ugly. So, I'm sorry, how did I what? Because when I substituted this in here, this is 6 times 1/2 to the 0 power, and 1/2 to the 0 power is 1, so I get 6 times 1, which is 6. Okay. Thank you for asking. Anything else? Okay. Or if you are using wrenches and sockets and stuff, 3/16, 3/8. And you have the added excitement of also knowing the millimeters, which are way easier, way easier. All right, so I want to find the a sub 0 term of the sequence and support with work. Now, what is the a sub 0 term? We were doing that before. This is 1, 2, 3, 4, so what would 0 have to be? 12. Super easy, right? We don't have to do any work, but this says find a sub 0 and it says support with work. So if you just write down a sub 0 equals 12, you are not getting credit. Does that make sense? Because again, nobody cares what you can do in your head. Yes, it's simple. So we're going to use this. If I want a sub 0, that's going to be equal to 6 times 1/2 to the 0 minus 1 power. Now, that's really enough to write and then write what the answer is, but I'm going to write a few more steps so I don't lose anybody. So this is equal to 6 times 1/2 to the negative 1 power. What is 1/2 to the negative 1 power? 2. So this is equal to 6 times 2. Oh, I just put 6 times 12. 6 times 2, which is 12. Okay. Not saying you have to write down every single step, because when it says support with work, you don't have to have a ton of work. You just have to show where it's coming from, and you didn't just pull it out of the sky. Okay, we good? All right. Now it says write an exponential form of the formula. And so that means we want an f of n, which we already had, but maybe that was intended to be a g sub n. I'm not sure because it isn't right anyway. But we have it already, and we could just rewrite it. But I feel like with some bad wording, what this is asking for is the one where we just have n and not n minus 1. I think that's why we also found this. So if I have 1/2 to the nth power, that's like n minus 0. So I need my a sub 0 term, which is 12. So we had been finding these. We just weren't going through the process of it. We're just using our logic, but that's fine too. All right, what questions you got? Okay, so I got the application problems on this next piece of paper, which will also go on page 56. All righty. Okay, so Tim released a helium-filled balloon that rose 200 feet in the first minute. In each succeeding minute, the balloon rises only 50% as far as it rose in the previous minute. So it's not rising 2 feet every minute. Clearly, it's not linear. Since it's a percent change, that's what tells us it's geometric. So since this 200 feet in the first minute, that tells me G sub 1 is 200. Okay? Write a general form, G sub n, that gives the number of feet risen during the nth minute of the balloon for the time in the air. All right, so in order to do that, I also need R. What is R, do you think? 1/2. Because 50% as far is half as far, right? So half. Then I want you to write down your generic form without looking up here or anything else, get it out of your brain, then we can check ourselves. Make sure you know it. Should be there by now. Double check that you agree. We agree? Okay. So in order for me to write this, G sub n is equal to, what's G sub k? 200 q times r, which is 1/2 to the n minus 1 power. And we'll just leave it there for right now. Okay. All right, so then it says, use the formula in part A to find the height the balloon reaches after 8 minutes. So the first thing we need to do is fill in this chart. So if in the first minute it rose 200 feet, how much did it rise in the second minute? 100. Then how much? 50. Then 25. Then 25 over 2. Okay, so in this case, and thank you for saying it as a fraction because it usually is preferred. It's gonna, when we're talking about actual applications of things, especially when it's like 50%, then decimals are okay. Okay, so it kind of goes from the pure math to the application, and we kind of ask ourselves, what makes sense here? And the fractions make sense, but decimals would be okay. So what would the decimal be here? 12.5. And then what's half of 12.5? 6.25. And then 3.125. Okay, do you see why when you get down this far, really the fractions are better? Like they're nicer, right? Because if you had to write them all down and you don't have a calculator, the fractions are way easier than the decimals. But we can go ahead and, what is it? You can use your calculator. It's 1.5625, I think. Yeah, that's right. All right, so let's go back and read this question here. It says, use the formula from part A, boom, which we sort of used it, we just used R, and to find the height the balloon reaches after 8 minutes. So is this my answer? No. If it said, how far does the balloon travel in the 8th minute, that would be my answer, right? But when it says, how far does it reach? Well, it rose 200, then 100, then a little bit more. So basically, we have to add all this up. So let me show you how you can show your work with this. If I want the sum of all of this, the sum of those 8 minutes, it's going to be 200 plus 100 plus ... plus 1.5625. Okay? That's showing what you are doing without writing them all out. You with me on that? But then to answer it, you literally have to add them all up. Okay? And I really don't think in a case like this that it would be a non-calculator situation. So go ahead and use your calculator and add all that up. It's 398 point what? 4375, okay? And 4375 what? Feet, okay? Okay, so let's pause here for just a second. We're not finished with our sentence, but I want to talk about decimals again, okay? Because grading your tests, some of it decimal-wise was a hot mess. You have to be correct to 3 decimal places unless it's stated otherwise. My suggestion to you and what I want you doing is just writing down the first 4 that you see. Don't round, because some of you don't know how to round, okay? So we just write down the first 4, that makes us correct to the first 3, and we move on with life. Now, if there are a bunch more decimals in the calculator, I have to use what is stored in my calculator to manipulate anything. Do not ever, ever, ever type a rounded decimal back in. Now, when you're typing these decimals in, these aren't rounded, right? Those are just, that's what it is. It is 6.25. You type that in. But if we, and this isn't rounded either, that's exactly what you get. But if you actually rounded something, then you cannot type that back in. You are not going to be accurate. And some of you lost points on some of that stuff. The other thing is, depending on, we'll talk about, the next one's about money. We'll talk about some rounding there. But anyway, just be very careful with that. All right, so the balloon reaches 3 points. So I can't stop there, right? I have to say blah, blah, blah after 8 minutes. And I got all of those words from the question. There's no embellishing. I'm not making up a story about it. I'm just pulling the words right from the question. Okay. We all good? Questions? All right. So then we have this big tech electronic advertises a monthly payment plan for the purchase of the best-selling tablet. Buyers pay $50 at the end of the first month, $55 at the end of the second month, $60.50 at the end of the third month, and so on for 1 year. And what will these payments be by the end of the 4th, 6th, and 10th months? All right, so that means that G sub 1 is what? 50. G sub 2 is 55. And G sub 3 is 60.50, right? That's what they're giving us from the question. I want to know what they will be at the end of the 4th, 6th, and 10th months. So I want A sub 4. No, I want G sub 4, sorry. G sub 6 and G sub 10. In order to do that, it would be nice to have a little function here. So G sub n is equal to G sub k times r to the n minus k power. So I can use, this is my G sub k, but I also need r. How can I find r? $55 over 50? Okay, and here do you think would be more appropriate, leaving it in fraction form or getting a decimal? A decimal, because I already have decimals in the question, plus it's money, so, and when you divide that out, you get 1.1. So r is 1.1. So when I write this out, I get G sub n is equal to 50 times 1.1 to the n minus 1 power. So G sub 4. So if this is a calculator question, which it is, we can use that. So G sub 4, that's going to be 50 times 1.1 to the 4 minus 1 power. Now when we go to our calculator, when you turn it on, new, no you don't want to save, you're going to add a calculator and you're going to add a graph every time. Okay, and then you can go back to the calculator screen. And you can type in exactly what you wrote down, 50 times 1.1 to the 4 minus 1 power. You can write it, you can put it in just like that. You don't even have to subtract if the numbers are weird. And then you hit enter. And then let me show you something else that I kind of showed you before Thanksgiving. I don't want to type that back in again, okay? It wasn't even that bad. But if I arrow up and I highlight what I just typed in, now I can hit enter. I can go back and I can change that 4 to a 6 to get my next answer. And then I can do the same thing and change the 6 to a 10 and get that third answer that I want. Okay? Now, we're talking money. If you're correct to 3 decimal places, that's fine. If it's money and you feel like you want to round, that's fine. But if I have to do something with these 3 numbers, I use the numbers that are stored in the calculator. Period, end of story. Okay, so we can say that G sub 4 is 66.55. G sub 6, so that would be 50 times 1.1 to the 6 minus 1 power. And that gives me, is it 80.53 when we round? Oh. Go ahead and write the other ones down. Then 50 times 1.1 to the 10 minus 1 power. And that is $117.90. Is that correct? Okay. So then it says, how much will this customer pay for the tablet with this payment plan? Well, how many months are they paying on this tablet? 12, because it says for 1 year, right? For 1 year, so that is 12 months. So what I want is I want the total, my total payment is going to be G sub 1 plus G sub 2 plus ... all the way to G sub 12, right? I don't want to find all these numbers. I don't want to keep typing that in. I didn't even want to type as much as I just typed for that. But I had you do it that way because I know that that's the way that most of you would do it. But that's why we add a graph. So we're going to go back to the graph, and we're going to put our function in there. 50 times 1.1 to the, and we can't use n, we have to use x minus 1 power. Okay? You're going to hit enter. You're not going to see anything. That doesn't mean that you're wrong. It's because your y-intercept is not on this graph. The graph is way higher up there because you start off with 50 bucks, right? We don't care that we can't see it. Doesn't matter because I'm not actually using the graph. I'm using what's stored in there. So when I go back to my calculator, where did we store that graph? F1. So if I do F1 of, oops, hit the wrong thing there. If I do F1 of 4, okay, so that's F of 4. Look what I get, 66.55. I could have done it that way. So when I add all this stuff up, I can do it all at once. I can say I want F1 of 1 plus F1 of 2 plus, oops, plus F1 of 3 plus, okay, so keep going until you get to 12 and hit enter. And while you're doing that, I'm going to hand out your assignment since we're running a little short on time here because I want to be able to get to that last question. Mm-hmm. You cannot use n, you have to use x. How many numbers did it was? 12, because it was 1 year. All right, so we can say a customer will pay, is it $1,069, right? And 21 cents for the tablet with this payment plan. Okay. So then it tells us to write a formula as a geometric sequence and as a function. Well, we already did that, right? So G sub n is equal to 50 times 1.1 to the n minus 1 power, and f of n is equal to 50 times 1.1 to the n minus 1 power. Geometric sequence, exponential function, very, very similar to each other. Okay, so then it says, what does the ratio represent in the context of the scenario? Well, the ratio is 1.1. What is 1.1 as a percent? 110%. So each month, you were paying 110% of the month before. So how much more are you paying each month? How much? If you're paying 110% of the month before, how much additional is it each month? 10%, okay? So the ratio represents, let's see, we can say, you are paying 10% more than the previous month. Something to that effect. Okay? That's what the ratio means, because you're over 100%. All right, what questions you got? Phew, we made it. All right. Get those, both of those pages go in on page 56.